Today, we are diving deep into the chemistry that's hiding in plain sight, all around you. You know, from the drink sitting on your desk to why a big ship floats but a tiny pebble sinks, it's all science, and it's happening constantly. So, let's get into it.
Oh, we've all been there, haven't we? You're trying to make the perfect iced tea or lemonade, you add that last spoonful of sugar and nothing. It just sits at the bottom, a sad little pile, no matter how much you stir. Why on earth does that happen? And is there a way to fix it?
So, what's really the difference between a perfectly mixed drink and, well, this gritty mess? It's not some kind of magic trick, I promise. It's all about what's happening on a scientific level inside these two glasses, and today we're going to unpack that.
All right, here's our game plan. We're going to start with the basics of what's in your drink, then get into the science of mixing. We'll find out what it means for a liquid to get full and how heat can totally change the rules. Then we'll shift gears a bit to talk about density, and that's how we'll finally figure out the secret to sinking or floating.
Okay, first up, let's go back to that perfect drink. You know the one, where every single sip tastes exactly the same. What's the science behind that consistency?
Think about something like an oral rehydration solution, or ORS. It's got salt and sugar in it, but it's not like you get one super salty sip and then a super sweet one, right? No way! That's because everything is spread out perfectly, completely evenly. And that's what scientists call a uniform mixture. So, to really understand how these uniform mixtures get made, we've got to meet the key players in this process. Let's break down a few must-know terms.
First up, we have the solute. This is pretty simple. It's the stuff you're adding in. It's the sugar you put in your coffee, or the salt you add to water to boil pasta. The solute is what's going to get dissolved.
And next, we have the solvent. This is the substance that's doing all the heavy lifting. It's the dissolver. And water, is basically the superstar of solvents. It can dissolve so many different things.
And when you put those two together, when the solute completely disappears into the solvent, bam, you get a solution. That's it. That's our perfectly mixed drink. Just remember that simple formula. Solute plus solvent equals a solution. Now, if you could zoom in with a super powerful microscope, this is what you'd see. See those little yellow particles, the solute? They don't just stay in a clump. No, they break apart and spread out all nice and even among the blue solvent particles. That's the real secret to why every sip tastes just right.
But, as we know from that sad pile of sugar at the bottom of our glass, there's a limit, right? A solvent can't just keep dissolving stuff forever. So let's talk about that limit. Scientists call it the saturation point.
Just picture this in your head. You take a glass of water, add a spoonful of salt, and stir. Poof! It vanishes. You add another one, still dissolves. But then you go for that one extra spoonful, and suddenly, no matter how much you stir, it just won't disappear. It swirls around and settles right on the bottom. You've officially hit the limit.
And this actually leads us to two important ideas. So, as long as the water could still dissolve more salt, we call that an unsaturated solution. But the moment it hits its limit, the second it can't take any more, it becomes a saturated solution. It's totally full. And this right here, this is the perfect visual of a saturated solution. The water has taken in all the salt it possibly can. That extra stuff sitting at the bottom is the clear signal that we have reached that saturation point. So what if you want to dissolve more? Is there a way to kind of bend the rules? Oh, absolutely. And the secret ingredient is basically a cheat code: heat. For most solid things, like our sugar and salt, turning up the heat means you can dissolve more of it. Just look at this chart. Hot water can hold way more solute than cold water can. And this is exactly why dissolving sugar in hot coffee is a piece of cake, but trying to do the same in iced coffee feels impossible. But here is a really cool twist. When it comes to gases, the rule is completely flipped upside down. The solubility of a gas actually goes down as the temperature goes up. And this is so important in the natural world. Colder water can hold more dissolved oxygen, which is exactly what fish and everything else living in the water need to breathe. Okay, so we've pretty much mastered how things mix together. But what about the liquid itself and the things we put in it? To really get why some things float and others just sink right to the bottom, we need to talk about a new idea: density. You know, this is a fantastic way to think about density. Picture a bus that is absolutely packed with people, standing room only. That is a high-density situation. Now, picture that exact same bus, but with only 2 or 3 people inside. That's low density. It's all about how much stuff is crammed into the same amount of space.
Now, the scientific definition is that density equals an object's mass divided by its volume. Mass is basically how much matter, or stuff, is in an object, and volume is just the amount of space that object takes up. So really, density is just a measure of how tightly packed all that stuff is.
Let's test this out with a classic example. We know that 1 liter of water has a mass of about 1,000 grams. But here, a full 1 liter bottle of oil has a mass of only 910 grams. So, for the same amount of space, 1 liter, which one is denser? Well, the water is. And that is the fundamental reason why oil always floats on top of water.
Wow, we've covered a lot of ground, haven't we? From mixing drinks all the way to crowded buses. So let's bring it all home with a quick recap and finally unlock that secret of sinking and floating.
So let's just run through the highlights one more time. A solution is that perfect, even mix of a solute and a solvent. But it can get full. That's a saturated solution. We learned that heat is our best friend for dissolving solids, but it actually pushes gases out of liquids. And it all leads up to this idea of density. How much stuff is in a space? Because ultimately, whether an object is more or less dense than the liquid it's in, that's what decides if it sinks or floats.
So now you are armed with the science of solutions and density. Look around you, at your kitchen, at the world outside. From the way your salad dressing separates to a log floating down a river, what everyday mystery does all this new knowledge finally solve for you?